Okay, our purpose here today is to figure out how to read the folder, how to use it as a tool to help you review. So if you would please follow along, beginning in reporting category number 1. Okay, at the front of reporting category number 1, you've got the 4 different flaps about the different types of geometry. That is just information. You need to know the difference, the basic differences between Euclidean and non-Euclidean, and probably more specifically, what's the difference between Euclidean and taxicab geometry. Would not be surprised to see a question on there dealing with taxicab. Inductive and deductive reasoning flaps down at the bottom. Those are just basic definitions for your information. The first thing that you're going to have that's going to actually function like something is at the top of the second page where the 4 flaps say conditional statement, inverse, converse, and contrapositive. You've got a label underneath there that says conditional statements practice cards, and in a Ziploc baggie you've got these guys that deal in different quadrants. You don't have to dig those out now, just kind of follow along with me. You may want to scribble down some notes as we go, or you can check the video on Edmodo if you can't remember everything. But basically what these little cards do is these are going to slip up underneath the 4 different flaps that are there, and then what you're able to do is you're able to flip open the conditional statement and you will read a conditional statement. Based upon that conditional statement on a separate sheet of paper, you can then ask yourself, what would the converse say, what would the inverse say, what was the contrapositive say, and then you can open the correct flaps in order to match up and see if what you wrote is correct or not. So you've got several different little cards that have different conditional statements as long as they're inverses, converses, and contrapositives to go along with them. So that's how that works. The next envelope down says, is that logical? Practice cards. And these are should be in your envelopes. And the purpose of these is to basically read over, like for example, it says determine whether the stated conclusion is valid based on the given information. If not, determine a counterexample. And it says given that angle A is congruent to angle B, the conclusion is that angle A and angle B must be vertical angles. Well, you need to decide, is that valid? Does being congruent make them vertical angles? And the answer to that one would be no, that's not a valid statement. Sure, being congruent, vertical angles are congruent, but not all congruent angles have to be vertical. Okay, so that's the way those work. So you just kind of read one side, decide is that a valid statement or not, flip it over, and it'll give you an answer and response. Next envelope down says Conjectures practice cards, and once again, these are going to be 2-sided, so you kind of read the front side, and it asks you to make conjectures about the different scenarios and situations that they have, so you can kind of formulate that thought mentally or write it down or whatever, and then you flip over the card, and the card should verify for you if what you were thinking was correct or not, and that's reporting category 1. So flip the page. Okay, the top of reporting category number 2. Okay, reporting category number 2, the 4 flaps at the top. You have cards in a baggie that say patterns to algebra, and they look like this: horizontal 4 rectangles, and just like with the one in reporting category 1, they slip up behind the 4 panels. You can flip up in any case. There's no telling how they might ask these questions, whether they may give you a pattern and ask you about a table or a process or an expression, or maybe they give you a process and ask about the expression or the table or the pattern. Okay, so you can kind of alternate on these practice cards. Okay, take one, slide it up underneath the 4 panels, and then pick a flap. Open up one of the flaps, look at the information that's hiding behind it on that card, and then you can kind of ask yourself, okay, based upon that information, what would those other 3 panels try to look like? Okay, to go along with that problem. Okay, so that's the way those 4 flaps are going to work in reporting category number 2. Underneath that, you got the draw a picture, and the draw a picture card should be in the envelope. And basically, it's pretty self-explanatory. They're giving you a written geometric situation, telling you about lines that are parallel or angles that are congruent or whatever, and you draw that on a piece of paper, and then you can flip over your card and you can look and see if you came up with something that is comparable to what the card has. Okay, so that's a draw a picture. The next one down at the bottom there is the Generalizing Geometric Properties envelope. Okay, and again, what they're going to do on these are the ones that's got different circles on it, different regular polygons. They're establishing basically a pattern, okay, an observable pattern. They're saying, hey, in this circle, these arcs are doing this, and this angle's doing that. In this circle, same arc, same angle, different measurements, okay? And they're kind of establishing it over and over again and then asking you to arrive at the conclusion. What is the relationship that is being demonstrated between these arcs and with this angle, okay, or with the exterior angles on these polygons and stuff like that? And once you arrive at what you think the answer is, you can flip the card over and it's got an answer and hopefully it'll match up. Okay. The next thing that you've got there is the compositions of transformations practice. Okay, the one that's got the 5 different flaps. Okay, so problem 1, problem 2, problem 3, and problem 4 at the top there. The way that's intended to work, okay, is I have a laminated graph here for you that's going to go along with these things. And I'll hand you out one of these to everybody here in a moment. Okay, but as you open up each of the flaps, the back cover of each of those flaps gives you some instructions. Okay, draw a triangle or figure out what's parallel to this particular thing or what's perpendicular to that, or is there a right angle, stuff like that. And you can use this little laminated sheet. If you have a dry erase marker, even a crayon or something, you can draw on these, and then you can erase and use it on a different one. Okay, so basically, as you open them up, you've got a different situation on the left, and then you've got the solution that goes with it on the right. So these are basically just practice problems that you can work with, and I'll hand you out these here in a little while. If you can't come up with anything to work on with these, I do have a few small dry erase markers, and I'll be happy to hand them out. Of course, you can get them at any store, CVS or Walmart or whatever. Okay. Um, Now, one piece of information that we did not get, and you probably go ahead and write it in, under the tessellation flap, we did not provide any information on that, so let me give you a basic definition for that now. Okay, tessellation is basically a recurring object that makes a pattern. A recurring object that makes a pattern. That's not to be confused with something that just a recurring pattern like a checkerboard or something like that. But like that example that's on the little tessellation flap, you see you've got some kind of a little lizard or gecko or whatever, and it'd probably be easier to see if it was in color. But that little lizard or whatever, he's just copied and repositioned over and over again, and in the process of him, he kind of interlocks and blocks out the entire paper. Okay, so that's basically what a tessellation is. On the types of transformations, the little envelope that's next to that, I got looking at the cards that they had provided for you, and I decided not to even run them off or waste your time with those because those cards were not really very useful at all. So that's how come your types of transformation envelope remains empty. You've got enough going on with the 4 problems up at the top of the page on transformations that I think you'll be okay. The 3 triangles at the bottom of the page, those are information only. So turn the page into reporting category 3. You've got 2 envelopes at the top of the page. One of them, it says cross-sectional area cards. Now on those cards that live inside of that envelope, what you'll find is you have, on some cards, you've got 3-dimensional objects that have a plane passing through them. And then on other cards, you have 2-dimensional polygons that go along with something. And the goal of these is to sort the cards to figure out which 3-dimensional object and plane cross-secting goes along with which particular shape that the cross-section would be. So this is kind of a match 'em up type of activity that you can use to practice on cross-sectional area. Next envelope says nets and 3D solids. Okay, so inside of there, you will have some cards that live, and you will find basically the same type of situation. Some of the cards show an unfolded net that goes with something, and the other cards are a term of some kind. So the goal is to figure out the net. If you were to take the net and fold it back up into a 3-dimensional solid, you match up the name that goes along with the net. So it's another matching type activity. So that's how that one works. The next one down, the one that has isometric and orthographic perspectives. This is one of the ones that lives in the plastic baggies. Okay, and again, you have the long horizontal rectangle that's got 4 different subdivisions on it. One of those is isometric, the other 3 are orthographic. So once again, what you do is you just slide this guy up underneath the 4 flaps that you have, and then you can either pop open the isometric perspective, have a look at the figure, and then decide what would the top look like, what would the front look like, what would the side look like, and then open those as you come to some answers. Or possibly you could put the new figure in there, open up the top, front, and side, have a look at the figure from its orthographic perspectives, and then try to decide what type of a shape is this isometrically, and come up with the idea, and then flip open the isometric tab. Okay, so you've got a few different examples of some practice that you could work with on that. Okay, over on the right hand side, you've got a twofold thing that says lines in geometric figures. Okay, this is also a baggie that you've got. And this is a little bit of a different type of a situation. Once again, this little laminated graph that I'm going to pass out to you, it's going to go along with this stuff. You've got some instructions on the part that you have glued in there, and those instructions can be done on the foldable itself. But these other cards that you've got, these supplemental cards, these are completely different situations than the one that you have in the foldable. Okay, so you can follow along on it, and you can say, okay, part A, it tells you to determine the slope of a line, or part B tells you to figure out a midpoint or something like that. That's where you've got this extra graph that you can write on and you can erase on and stuff like that. So you can use those different scenarios to help you study as well. Okay. The next thing that you've got is the hands-on and the using formulas methods that are down there. Okay, and unless I am mistaken, there is no additional practice information that goes along with that. It is simply an understanding. You have all those extra graphs in there. You can plot a couple of points in there for yourself on those graphs, and you can figure out length using the 2 different formulas, or you can plot a couple of points, do the hands-on method of rise over run, and then also do the formula figuring out rise over run. And if you've done them both correctly, your answer should match. And same thing with midpoint, and same thing with the equation of a line. And you can use the extra laminated graph that you're going to get to practice that as much as you want, because you can invent 2 points in any positions that you want in there, and you can figure out lengths and distances and slopes and equations, all that you want, using that as well. So that's where the practice will be for the hands-on and the using formulas. Okay, so turn the page into reporting category 4. Now, some of these things in here really need some further explanation. Okay, you've got 2 foldables on one on surface area and one on volume right off the bat, and there's no extra information going along with that. The best I can figure is that their intention there is that you actually figure out the surface area and the volume of the figure that they've provided there. Okay, so they've just given you an example of surface area and volume, and actually I got an email earlier today that has some extra surface area and volume figures like these. So if you need some extra practice or whatever, I have it, but I simply did not have time to run off 75 extra copies and distribute those today and cut those out today and stuff like that. We're out of time. Okay, so if you feel like you'd like more surface area and volume for composite figures, composite shapes, I can get you some extras. Just let me know. There is nothing to be done with the formula chart fundamentals and that foldable that has volume and circumference and surface area and area on it. That is an information only. The colored foldable down at the bottom that says surface area or volume on it. Okay, when you've got everything all cut out, which you should have, there are 9 cards that go in these, and these 9 cards are different descriptions that can either be interpreted as surface area type information or volume type information. So as you sort these out, the idea is to position them into either the surface area or the volume pocket accordingly. Okay, so that's all that is. The little pocket, little folder next to it says congruent triangle theorems. The little slips that are inside of that, you will see, have various information. Okay, some of the cards will have a pair of congruent polygons, pair of congruent triangles on them due to some possible explanation. Okay, and then you have some other cards that will say yes, they are congruent by a particular shortcut theorem, and those shortcut theorems, they were side side side, side angle side, angle side angle, okay, stuff like that. Okay, so the idea is to match up which explanation goes with which diagrams. That's how that one works. Okay, over on the other side you have the circle that's there, and the circles that we put on there, we have some theta measurements, we have some radius measurements. You can actually compute that arc length or compute that area of the sector, but that is kind of what that's intended to be, is a one-shot type of example. And of course you can invent different angle measurements, you can invent different radius measurements, and you can calculate those as well for arc length and for area of a sector. So that's what that is. The area of the regular polygons that's at the center top, you've got two polygons in there. A lot of people ask the two little fold outs, one of them says easy and one of them says treacherous, and people have asked what is the difference between the easy and the treacherous. Well, you've got one example in there that hands you the apothem and hands you a side length. That is an easy calculation, so that's actually the one they're referring to as easy. And then they have a different figure in there that does not provide you anything except for perimeter, and you are left to come up with everything else. That's treacherous. That's kind of like a best case and worst case scenario as far as regular polygons are concerned, but that's what that foldable is for, is it's giving you two practice questions on area of regular polygons. The other thing across the top row there says area of composite figures. Okay, and once you've got those cut out, again, what you have is, I think, 8 little cutouts, and it's got various composite shapes on it with their measurements. And if you cut them out the way I said, you should have some extra space on there, and you're intended to actually do the calculations to figure out, get a little practice on area of composite figures. Okay. Down below that, you've got the two smaller foldables. One says dividing a complex shape into similar shapes or subtracting off cutaway shapes. That's a really complicated way of saying composite polygons. I don't know what they were doing there. But again, they're providing you with a couple of examples. Their intention there is that you will actually calculate those two different shapes based upon the information that they gave you. Okay. Um, the Pythagorean Theorem down there at the bottom, there is one piece of information that I think is important, and I left it off yesterday, so I would like you to add possibly underneath the C. Okay, underneath the C on the Pythagorean Theorem foldable. Okay, so you got your little triangle up there, and you've got the five squares underneath. So I'm going to add in underneath that guy down here. Okay, we all know that in a right triangle, Pythagorean theorem says that if you have a right triangle, a squared plus b squared will equal c squared. Okay, but that's not the only place that we've ever seen Pythagorean theorem. We've seen it in other types of triangles as well. As a matter of fact, we have seen that it is possible that a squared plus b squared may not equal c squared. For example, perhaps a squared plus b squared is larger than c squared, or a squared plus b squared is smaller than c squared. Well, when these two situations happen, it means that we do not have a right triangle, but that's not the end of the information that can be found. Okay, we also can decide whether it is not just right, but we can decide if it is acute or whether it is obtuse. And this is a very common thing that the tests have asked us to do in recent years, so we better know. Okay, so here, this top one, the statement here is that the two legs, the sum of the squares of the legs outweighs the weight of the hypotenuse squared. And down here it suggests that, the hypotenuse being squared is heavier than the sum of the squares of the legs. Okay, so when this equation tips, when the inequality tips one way or the other, we need to know what that means. Okay, well, let's think about the nature of a triangle. Okay, the biggest side of the triangle is referred to as the hypotenuse. The biggest side of the triangle is going to be across from the biggest angle. Okay, now this first statement suggests that the hypotenuse all by itself cannot win the battle against the two smaller legs being squared and added together. Okay, if that's the case, if the hypotenuse is going to lose that battle, then what that suggests is that the hypotenuse was small. Okay, and if the hypotenuse was small, what would you find across the triangle from a small hypotenuse? You would find a small angle. What's our word for small angles? Acute. Okay, so if the Pythagorean theorem tips that direction, then you're looking at an acute triangle. Along the opposite lines, what happens if the hypotenuse all by itself out there being squared wins that battle and the scale tips its direction? Okay, if the hypotenuse all by itself wins that battle, that means it is a big hypotenuse. Across from the triangle from a big hypotenuse, you would find a big angle, and our word for big angles is obtuse. Okay, I would not be surprised at all if you see no less than 3 Pythagorean theorem questions on the test. 2 of them are usually straightforward right triangles, solving for missing information, stuff like that. And 1 of them will be not a right triangle, and you better be able to classify it as acute or obtuse based upon which direction the theorem is tipped. Okay, so a little information there, and that's all for reporting category 4. So turn the page into RC5. Okay. The next information there is you have at the top, you've got information about dilations. Okay. Once again, this is kind of practice only. It is giving you a set of problems and a graph inside. Okay, and you're intended to work on and practice and solve the problems. And once again, you can use the extra little laminated graph that you're going to get in order to practice additional problems, and you can make up as many as you want in order to practice. Okay. The next thing down says proving triangles to be similar, and then you have a label that goes along with that that says similar figures practice cards. Okay, and that refers you to a baggie, and you have some extra figures that go along with that on those cards, and it's got all kinds of different shapes, and they're basically giving you some scenarios saying the figures are similar, solve for the missing information, or based upon what you've got, are the figures similar? Okay. Okay, now down at the bottom of the page, okay, hopefully you got the information on the change of dimensions filled in. If not, it's posted on Edmodo. You need to get that done. It's information only on watching out for dimension changes, first dimension, second dimension, third dimension, how to set up the proportions, stuff like that. And then the other foldable, the little accordion guy down at the bottom of the page, again, the instructions are on Edmodo. Hopefully you got that filled in. And again, it is information only, but the skills that go along with that foldable are found on the other page. These are the 3 envelopes you have that say sine, cosine, and tangent. Okay, now on the cards that go with them, the 8 cards, you're supposed to sort them into the proper envelopes. Unfortunately, I think a lot of people, for what that means is they looked at the card and they flipped it over and they go, oh, this one says sine on the back, so I'll put that in the sine folder, and oh, this one says tangent on the back, so I'll put that in the tangent folder. And that's not what it's intended to do, because when these triangles show up on the test, they're not going to come out and go, hey, pick me, I'm cosine. Okay, it's just going to be a triangle, and if you decide to use trigonometry on it, it'll be up to you to decide, what function do I use? Okay, so Katoa to pick your correct function. So these cards are intended for you to look at the information that is provided for you and then make a decision. Is that sine? Is that cosine? Is that tangent? Pick the correct function, work it out. Okay, and then you can flip it over and you'll be able to see, did you pick the correct function, and did I arrive at the correct conclusion from that? Okay, so that's what those 8 are for, not just to flip them over and stick them in the appropriate folder. Okay, they're practice cards for that. The only other thing that I have to offer you for this, of course, is on the back, you've got the star reference chart. And another thing I'm going to pass out for you, I've got a griddable that's on here. I hesitate to say I don't think anybody needs to practice filling in the griddable stuff, but just remember when you're looking at griddable information, when it comes down to it, it's not necessary to bubble in the positive in order for an answer to be positive. It's not necessary to bubble in a decimal point if the answer doesn't require it. And it's not necessary to bubble in zeros unless they actually change the answer. Okay, so my suggestion is don't bubble in positive, don't bubble in the decimal unless it's needed, and don't bubble in any zeros unless they are needed for the answer. Okay, only fill in and bubble in that which you need to convey the answer. Because if you make a silly mistake doing something that wasn't needed to begin with, the silly mistake is going to count against you. Okay, so only do what you have to do. And on this extra page, you've got a little bit of extra blank graph paper. On the back, they've got triangular graph paper. I'm not really sure what's for, and I don't think you're going to get any of this on the test. But anyway, that'll be the materials. At this point in time, it's pretty much on you at this point. Okay, the test is literally 3 class days away. Wednesday is the day. Um, your folders are your tools. Okay, at this point, you're going to get out of your folder exactly what you put into it. We've put a lot of effort into it, getting it built. If you don't ever touch it, it's not going to help you in the slightest. Okay, for those of you that have been, your tax people and may have been thinking, well, this is stupid. Why do I need to do this? Well, like I said, you do have a semester exam, coming your way, and it's the same stuff. The year is not over just because tax is over or just because end of course is almost over. We still have material that we have to cover. We still have grades that we have to finish up. Okay, so at this point in time, your folder can be basically considered to be complete. If you have been keeping up with everything, should be good to go. It ought to be a complete study tool. If you have any questions on how any of the problems work or what the correct answer should be or whatever, I don't have a key that goes with all this stuff, but I'll be more than happy to work out the questions to verify that you got the right answer or not. All you got to do is just walk through the door. Okay, come in and let's talk about it. Okay, so that is basically it. The test is in 3 days. Let's get ready.